Hi and welcome to the video on the 3 index laws. By the end of this video you should be able to work with all 3 of the index laws and know what they are. So let's take a look at law number 1, the multiplication law. If I wanted to do 3 squared times 3 to the power of 5, then what I would need to do is do 3 squared, which means 3 times 3, and then 3 to the power of 5, which is 3 times 3 times 3 times 3 times 3. Now you'll notice that all I'm doing is multiplying 3 by itself a whole bunch of times here. In fact, if I count them all up, I can see that I'm multiplying it by itself 7 times. So to simplify this, all I'd have to write is 3 to the power of 7. Let's look at 2 to the power of 4 times 2 squared. So 2 to the power of 4 is 2 times 2 times 2 times 2, and 2 squared is just 2 times 2. And again, I'm multiplying a number by itself, in this case 6 times. So to simplify this, I get 2 to the power of 6. Now I don't need to know what the answer is. I don't need to know what 2 to the power of 6 is or 3 to the power of 7. I'm just looking for a way to simplify them. What do you notice about the powers in the question, comparing them to the power in the answer? See, for the first one I've got 2 and 5, and my answer is a power of 7. And in the second one I've got 4 and 2, and my answer is a power of 6. If you notice that I'm adding the numbers in the powers in the question to get the answer to the powers in the answer, then you'd be absolutely right. And this brings us to our first law, that when we multiply terms with the same base, that is, in the first question we're multiplying 3's, and in the second question we're multiplying 2's together, then all we need to do is add the powers. That's law number 1. Law number 2 is the division law. So we're going to be looking at divided by questions. This question is 3 to the power of 5 divided by 3 to the power of 2. And again, I'm going to write these out in expanded form. 3 to the power of 5 means 3 times 3 times 3 times 3 times 3. And when I divide, I can write it like a fraction. And that's what I've got that line there for. It's a fraction line. And I'm dividing by 3 squared, so 3 times 3. Now what I can do is I can cancel any 3's at the top with a 3 down the bottom. So for example, I might cross off the last 3 and the second last 3's. This is going to leave me with 3 times 3 times 3, which I can write as 3 to the power of 3. Let's look at another one. 2 to the power of 6 divided by 2 to the power of 5. Now 2 to the power of 6 can be written as 2 times 2 times 2 times 2 times 2. I'll do that 6 times. And 2 to the power of 5 will go on the bottom of my fraction as 2 times 2 times 2 times 2 times 2, 5 times. And again, I can cancel, or I can cross off any 2's at the top with 1 down the bottom. So I'll cross them off in pairs. So I'll cross off those 2's, those 2's, those 2's, those 2's, and those 2's. This leaves me with just 1 2. And I can write that as 2 to the power of 1, or just 2 for that matter. Now I'm going to ask the same question I asked for the first law. What do you notice about the powers in the question compared to the powers in the answer? So in the first question, I've got powers of 5 and 2, and I end up with a 3. And in the second question, I've got powers of 6 and 5, and I end up with a power of 1. If you said that you're subtracting the powers, then you'd be absolutely correct. When dividing terms with the same base, that is, with the same bottom number, in the first case it was 3's, in the second number it was 2's, if we're dividing terms with the same base, then we're going to subtract the powers. That's law number 2. Finally, we're going to look at law number 3. These are powers of powers. What does that mean? Well, in the first question, I've got 4 to the power of 3, and I'm bringing that inside the bracket to the power of 2. This means I'm going to take 4 to the power of 3, and I'm going to multiply it by itself 2 times. Now, I do need to use law number 1 to help me solve this, to help me simplify it. I am multiplying 2 powers there with the same base. This means I need to add the 3 and the 3 together, and I'll get 4 to the power of 6. Let's look at the second example. 2 to the power of 8 to the power of 3. That means that I'm going to take 2 to the power of 8, and I'm going to multiply it by itself 3 times. Using law number 1, I need to add those powers together. 8 plus 8 plus 8 is 24. What do you notice about the powers in the question compared to the powers in the answer? So in the first question I've got 3 and 2, and in the answer I've got a power of 6. And in the second one I've got a power of 8 and 3, and in the answer I've got 24. If you said that you would multiply those powers together, you would be correct. When taking a power to another power, keep the base the same and multiply the powers together. Those are the three rules. And what we're going to do now is we're going to use those three rules to solve or simplify some questions. So in the top right hand corner of your screen right now, I have the three laws. When multiplying terms with the same base, we add the powers. When dividing terms with the same base, we subtract the powers. And in the third law, when taking a power to another power, we keep the base the same and we multiply the powers together. Add, subtract, multiply. Let's look at our three questions. Question number 1 is 5 to the power of 6 times 5 to the power of 10. And we just want to simplify. We don't need to know what the actual answer is. We don't need to know what the basic numeral is. We want to write this in a simpler way. Here's how we go about it. It is a multiplication question. It's got a times question, which means that we're going to use law number 1. We have the same base. We're multiplying bases of 5. So our answer is going to have 5 to the power of, and I'm going to add my powers. 6 plus 10 is 16. Second question, 10 to the power of 10 divided by 10. This is a divided by question, so I'm going to subtract the powers. My base is 10, so my base will be 10 in my answer. Now here's a tricky part. There's no power here, so what do you think we do? Well, when we have a 10 by itself, that's not 10 to the power of 0, it's actually 10 to the power of 1. So when I do 10 to the power of 10 divided by 10 to the power of 1, I'll end up with 10 to the power of 9. Doing 10, take away 1 to get 9. Finally, 7 to the power of 4 to the power of 5. When taking a power to another power, I keep the base the same, and then I multiply the powers together. In this case, my base is 7, so 7 will be my base in my answer, and then I'm going to multiply my powers together, 4 times 5. Simplifying this, I get 7 to the power of 20, an extremely big number, but we just want to write it in index form. And those are the three laws that you need to learn and remember when you go through your exercise. So what should you write? The heading 3 index laws is a good start, as well as what the 3 index laws are, and finish off by writing those 3 examples out with their answers. If you can use those laws, then you're going to be fine with the last exercise in tomorrow's lesson. And that's it. Hopefully now you know how to work with those 3 index laws, or at least you have an idea, and tomorrow you can practice them. Good luck.